So we may have imagined that data analytics is a black box sebagai satu kotak hitam. When we throw in data, it will carry out complex mathematical operations and it will produce some kind of magical result. This expectation is not wrong. However, to be able to arrive at the point of having a magical result, it will require huge organizational efforts in addition to technical know-how. So biasalah kalau our leaderships always ask for results yesterday and when they ask today. So we always need to be prepared. So the stakeholder engagement is very, very critical. So in reality, sebenarnya, a lot of time will be spent on the first two parts, which is collecting data and organizing data. When we complete the first two, the next three here I illustrate is the creating a model, use a machine learning model to work with the data, and then deploy the application, which will be an iterative process that is continuous to meet the business objective. In fact, the first two activities just now that I just mentioned, which is collecting data and organizing data, is also a continuous iterative efforts. So among other things, one of the challenges is when the data structure change, when you have a new column or a new data types, it may break the application and which we will have to review. This is very common, so as simple as adding one new column. So I think you may have experienced this before, and it will not be always perfect the first time. So another way to understand the context of data analytics process, it can be broken into three parts. So I just make this representation into collecting data, processing data, and visualizing data. Here I would like to highlight that we'll be facing three types of data, very, very common, which is the first one is the real-time data, near real-time data, and batch data. Although ideally, we always wanted it to be perfect and ideal and accurate to be real-time. Most of the time, it cannot happen because the nature of the data is just not existent in that manner. It can be a batch data of 1 hour. Most likely, perhaps we can only come to a point to having 1 day batch data. So to have a real-time data is a luxury and only can be come to that manner when we have the right infrastructure in place. Basically, it will require a lot of collaboration, preparations. So, so before we go further on data analytics on AWS, let me provide a bird's eye view of generic data analytics building blocks. This is a very good diagram by Gartner representing end-to-end machine learning and analytics architecture. It is valid for both on-premise and cloud. So if you see on the left-hand side, we are acquiring two types of data. This is a very busy slide, but it's very something that you want to refer to always as a primary architecture. On the left-hand side, you have data in motion and data at rest. So we are playing with these two data, in which data in motion may include most of the time machine logs, IoT feeds, which we have the opportunity to ingest in real time just because it has not landed into any database yet. So data at rest provides billing and other transactional data. So so on the right-hand side, after all the processing of the analytics, after we organize and analyze the data, we are then able to develop the dashboards. So this is the key product, and in fact, the most important product that anyone will see. The top management will most of the time we are looking for a pretty interactive output of a dashboard, even though it has come to a long journey from raw data to data engineering. The final outcome is the most important piece, and it will require a lot of efforts by the project manager, for example, and the data analyst to present and get the feedback. So I will touch a bit on this iteration process after this. Okay. So next slide. Okay. You all still here? Okay.
Yes, clear.
All right. Okay. So I got to know that UPM, the program, is currently using Power BI and Tableau in this program. I think that is a very nice selection because Microsoft Power BI, if you look at on the diagram on the right hand side, the magic quadrant of the analytics and business intelligence platforms, the most popular among many is Microsoft Power BI. Next one is Tableau, which is more expensive, and the rest. Even though it is illustrated here, it doesn't mean that the rest are not good. It's just that it comes to a point where Microsoft has this ecosystem that is able to push the product. Microsoft Power BI indeed can deliver. However, the rest is also very important and is part of the ecosystem. So you will find if you jump into another organization, they will not be using such product. They will be using something else. The quadrant on the center is the magic quadrant for cloud AI developer services. You're looking here. You're looking at three key service provider, which is the top is Amazon Web Services. Second is Microsoft Azure. And the third is Google Cloud Platform, GCP. So in Amazon Web Services refer themselves as AWS, Microsoft Azure, and GCP. And the fourth contender is IBM, which is a bit behind, but they also have their strength. So on the left-hand side is more niche players from my perspective. There are data science and machine learning platform. They are good in doing things that they do. For example, Data IQ are able to do AutoML, for example. They can do automatic, they can automate data ingestion to some extent and be able to present it quickly on the fly for review and presentations and investigation, of course. All right. Other than that, I would like to highlight one product here. If you look at still quadrant on the left, KNIME, K-N-I-M-E, and Rapid Miner. KNIME, KNIME is a very interesting product because it is a GUI-based platform that is able to connect with many type of data sources. In addition, it is open sources and it's free for the desktop versions. It is able to produce pretty visualization on the desktop. Okay, I hope this will provide open our eyes to explore all kinds of platforms because they are our friends, and we need to be able to be comfortable using or switching to any of these. Some of this platform is not free. However, some are freely available. For example, Amazon Web Services, although it is not free, it comes with many ways to get on board for first year free, for example, and you should try to explore the platform. Okay, so let me go further into architecture benchmark on the topic number 2, the second part of the presentation. All right. So this is a brief summary of the difference between on-premise and on-cloud. I hope that you are familiar with this comparison. In the industry, to some extent, we always do things on-premise because we are comfortable with the security, we are comfortable with the having the physical server at hand. However, in the past many years, in the past 10 years or so, cloud computing has emerged to be an alternative that we should consider. First of all, because one of the key reasons for on-premise not to be preferred, because on day one, on-premise deployment will have two certainty. The first certainty is it will be over-provisioned, and the second certainty is the reverse, under provision. There are no certainty for an on-premise to be exactly per requirement, because it's all based on forecast, and forecast is always wrong. Hence, cloud computing provide the opportunity for business owners, industries, and agencies to be flexible, to deploy only what they want, and the cost will be on subscription based, on use based. More importantly, in data analytics area, we have various technologies. It's quite impossible for the planners to be able to identify and provision everything from day one and be exactly that and not moving. In which cloud computing will be, for example, AWS will be able to provide an options and opportunity for us to switch the method of ingestion, for example, switch the technology to some extent, and be able to maximize the time and optimize the outcome that we wanted. All right. Okay, so just briefly, if you look at this diagram, this is a comparison between four potential architecture. At the bottom, it's very interesting. At the bottom is a representation of how open source softwares are being put together to be able to ingest the data, organize the data, and visualize it without without having anyone to charge, provided you have the hardware. So starting with Minify and NiFi, where you have an opportunity to use a GUI based software to ingest data. You use Spark streaming to organize and stream the data into a specific columnar table, for example, and store the data using HDFS, for example, and visualize into Kibana. So this is virtually free, but no such thing as free lunch. In fact, for this deployment, it will require an exact or capable machines to deploy every of this, and we wouldn't know the scale, exactly the scale of the storage from day one, and most likely we will require a yearly upgrades of the hardwares. All right, that's not inclusive of electricity forecast and space forecast. As an alternative, you have this AWS IoT architecture, where it uses its own services referred as Kinesis streaming and Kinesis analytics, and storage such as S3 and DynamoDB. And here it uses Amazon QuickSight to visualize the data. Similar to Power BI, or in GCP they call it Cloud Data Labs, Data Studio. Amazon QuickSight will be able to visualize the output to our needs and requirements. All right. So showing this as comparison, we must understand what are the options out there so that we can navigate and modify and amend as we need to. All right. So here, this slide, this is a benchmark of how we do if we want to do it on premise. So as an organization, in my previous work with one of the service provider, we uses Cloudera for on-premise deployment. Rather than using really open source, Apache licensed open source, Cloudera come out with an enterprise version of this open source, put them together, that build a data lake for us to ingest various data such as network data, billing data, CRM, ordering, usage, inventory, and also some of the real-time data from the sensors into the data lake. In the data lake, when the data come into the data lake, it is our opportunity for us to then play with the data and investigate and explore towards the outcome that we wanted it to be. So when the use case, the business case come, we will then be able to use the infrastructure to produce the outcome. So what is missing here? What is missing here is the UI. So this Cloudera Enterprise Data Hub does not has its own UI. So most of the time it is dependent to third-party UI, for example, Power BI or Tableau or Click, for example. Okay. So let's go on. So this is one of the most important point that I would like to present here today, which is the AWS Smart Manufacturing reference architecture as part of this presentation, where living on the cloud with using AWS technology, we are going to have options of building blocks for us to use. These building blocks are basically standalone. For example, here, if you look at the AWS Cloud, the first block, SageMaker, standalone on its own. However, it can interact and work with any other components within AWS Cloud. So there are basically a complete product of its own. Nonetheless, when it works within an ecosystem, it can deliver the business result that we want. So this is an example, again, an example of a reference architecture for smart manufacturing. There are other reference architecture for other use case as well that we can emulate. Not necessarily we use all of this because each will come at a cost. Each will come at a cost, and we should select what we want and need at the time to deliver our business objective. So let me go to the third part of the presentation. So I still have time. What makes a data analytics team? So quickly, so being in data analytics or data science is quite tough because most of the time, as a fresh grad, you are expected to know a lot of things. I put it here, you are expected to have a 10 years of work experience because the time taken to know all this, you need to know scripting, you need to know one language, you need to know the visualization. It may require a lot of investment of time. So to the extent that we need to start early. So in Sarawak, they provide Raspberry for free for primary school students. So it is a challenge for a fresh grad of today's not to know Unix command line, for example. If you do not know Unix, you want to do data science, it is going to be a very big challenge. So there are, from my perspective, I've seen a few software engineers that they are struggling with Unix command line. So it becomes a skill set that we must have, to the extent that, again, Sarawak is purchasing Raspberry Pis for their schools to perhaps to provide to every and each of them a Raspberry Pi for their experimentation. That's a good start for an IR 4.0 oriented ecosystem to flourish. Okay, so the next slide that I want to share is the roles in data analytics team. again, data analytics team is not a one-man show. In addition to data scientists, as per our presentation to made earlier just now, we have a domain expert. We also have a data scientist that does the focus on the algorithms, for example, and we have the data engineer, which is very, very important. In fact, data engineer is the man or lady that is behind the curtain that will make a lot of difference. Data engineer know everything, and because he knows if the data is true or not, or if his data is not representative or it's just an assumption, or if there's something wrong with the data. So to some extent, we need to be very, very close to data engineers so that we are able to know what we can do actually with the data. So the last role that on the right hand side here is the developer role. That is the one that make it pretty, make the visualization to be digestible to the audience. All right, so let me share the last part of the presentation here. So just a brief of this method, CRISP DM method. This is an old methodology. I saw this much earlier when big data was hype a long time ago. Since then, it is still very relevant. If you look at the process, it's very relevant. However, it has been taken over by agile method that our presenter earlier just mentioned, in which we are going to use mainly design thinking process. So what I mean by design thinking is that we are true to what the customer wants. So we must empathize with the customer to define the problem statement so that we can ideate correctly, so that we can develop a prototype and we can test if our empathization is correct or not. To some extent, this will iterate so that we are able to produce something that is meaningful. So this is a key challenge and key problem that a development team must focus their time on, rather than meeting internally. If we have a meeting, 90% meeting, internal meeting, 1% external meeting with customer, it's very, very become a challenge, because we need to increase the time engagement with the customer so that we can understand them better. So last but not least, this is a development more focused on the data science development process itself, in which we look at the raw data and we apply pre-processing to the data so that we can choose the right model to develop the application. So I will be sharing this slide for your further review and reference. I hope it can be beneficial to everyone. All right.